Lesson 8A is on solving linear quadratic systems of equations. In Algebra 1, you started working with just solving linear systems, which is when you had a straight line intersecting a straight line. And in these cases, you're going to have one line with one parabola, which is a quadratic. So your equations would look like y equals mx plus b and y equals ax squared plus bx plus c. So you're going to have a linear being combined with a quadratic. Now, just like you had special cases in linear systems, three things can happen when you're talking about linear quadratic systems. The first scenario is where the linear line or the linear equation never comes in contact with the quadratic equation. And in that case, you're not going to have any solutions because a solution occurs when the two things intersect. The second situation is what you see here, which is where your linear only meets up with your quadratic in one specific place. So it's possible that you just come up with one solution. And then the last scenario is when your line actually crosses through the quadratic in two separate places. And so this is what's going to happen probably most often is you'll come up with two distinct solutions. So you'll have a point of intersection for this spot, and then you'll have a separate point of intersection, which is a separate solution at this spot. All right, so when you're solving linear systems with quadratic systems, just like in Algebra 1, when you solved the linear systems, you had different methods. You had the substitution method, the elimination method, and the graphing method. So we're going to go through those as well. You'll never be required to do one method over another. In this case, I'm going to show you the substitution method and why that's a good method to use on this one. If you have a situation where a single variable has been isolated, like in this case we have y being isolated, then this is a good reason to use the substitution system or substitution method. So what you're going to do is you're going to take the other equation, and wherever we have y, we're going to replace y with this equivalent amount, negative 2x plus 1. So that's going to go here. So it's going to become x squared plus 3x equals negative 4. And instead of that y, I'm replacing that with the negative 2x plus 1 minus 2. Okay, so now my equation, since I only have one equation, only has one variable in it, and I'll be able to solve it. So I get x squared plus 3x. I'm going to distribute the negative 4 to the negative 2x, and that's going to give me a positive 8x. And then the negative 4 to the positive 1, and that's going to give me a negative 4. I'm going to combine like terms on each side. Those two stay there. I have an 8x and then a minus 6. Now with any quadratic equation, you always want to set it equal to 0. So I'm going to move this 8x over here, and I'm going to move this negative 6x over to this side so that my quadratic equation will now be equal to 0. Okay, at this point you're just solving a quadratic equation, so you have lots of options. You may solve it by factoring if it's something that's factorable. You may solve it using the quadratic formula. Lots of options. So I'm going to go ahead, even though yes, this is factorable, I'm going to go ahead and use the quadratic formula just in case you guys come across ones that aren't. So x equals negative b plus or minus square root b squared minus 4ac all over 2a. All right, so in this case, a is 1, b is negative 5, and c is 6. And that just comes from these coefficients in the quadratic equation. So I'm going to get x equals negative 5 plus or minus the square root of negative 5 squared minus 4 times 1 times 6 all over 2 times 1. So x equals 5 plus or minus the square root of 25 minus 24 over 2. So I get x equals 5 plus or minus the square root of 1, which is 1, over 2. So that's going to give me 5 plus 1 over 2, which is 3. And that's going to give me 5 minus 1 over 2, which is 2. So now I know that x could be 3 and x could be 2. I need to figure out their y values. And the way I go about getting their y values is I come back to this equation right here where y equals negative 2x plus 1. So if y equals negative 2, and I'm going to fill in the x with 3 plus 1, that's going to give me a negative 6 plus 1, which is going to give me a negative 5. And then I'm going to do it again with this other x. That's going to be negative 4 plus 1, which is negative 3. So I have two solutions to this problem. And the first one is 3, negative 5, and the other one is 2, negative 3. And I can check them by plugging them back in, and it has to work for both equations. They both have to work for both equations. That's how you would check that. All right, the next option, instead of doing the substitution method, is doing the elimination method. And the reason I would do the elimination method is because these guys are lined up right now. They're the same variable. They have the same coefficient. So all I have to do is negate one set of them, which means change everything to its opposite sign. And then I can just add down. Y plus negative y is 0. Okay, I don't have any x squareds to add it to, so I'm just going to bring that one down. I have a positive x and a negative 2. So remember, all I did was add down. And the reason this was a good option is because I had those guys lined up. So then you have your quadratic equation, which you can solve. The last time I did the quadratic formula, this time I'm just going to factor. So this guy factors as x plus 2 and x minus 1. So when I solve those, I get x equals negative 2 and x equals positive 1. And then I'm going to take those answers, and I could plug them in each one, or I can just do it there. So my y value is going to be my x value squared. So y would be 4. And y is going to be 1. So my two answers are negative 2, 4, and 1, 1. So this is going to fall in that same situation where you'll have two solutions. Now the next example I'm going to do using the calculator. So the first thing you want to do is go to your y equals screen, type in the two functions, y equals negative x minus 3, and the other one is y equals negative x squared plus 2. When you hit graph, you want to make sure that you can see all the points of intersection. So I can see that this line is going to cross that quadratic right there and right there. If it's not right, you need to change your window so that you can see that. So then I'm going to go ask the calculator to find those points of intersection. So I'm going to click second, trace. I'm going to choose option 5. And I'm going to have to go through this process once for each point of intersection. So in this case, I'm going to have to do it twice. So when I do that second calc or second trace 5, the first thing it does is says, well, what curve do you want to intersect? And it defaults to y1. So I'm going to move my arrow using the left and right arrows closest to this particular curve I'm going to left it over, and then I'm going to hit enter. And then it's going to say, well, what do you want to intersect it with? So it's going to default to y2 since it's already chosen y1. I'm going to move my arrow so it's pretty close to that point of intersection. I'm going to hit enter. And then for whatever reason, the TI calculator has you guess. So I'm going to um, just hit enter for the guess, and then I know that I'm going to have my final answer when at the bottom it says intersect. And so the answer to this one is going to be x equals negative 1.791 and y equals negative 1.21 or negative 1.208. And and then I'm going to have to repeat that same process, but moving my arrows closer to the second point of intersection. So you can always do these in the graphing calculator as well. So let's just run through one more example. Um, in this particular example, um, I'm going to choose the elimination method again because they're set up to do this. So I'm going to have to, so that my y's will cancel out, I'm going to have to change all of my things here. So these will cancel out. I have x squared minus 4x equals 4x minus 16. It's a quadratic, so I want to get everything equal to 0. So when I move this 4x over, I'm going to have a negative 8x. And when I move this 16 over, I'm going to have a positive 16. Again, this guy factors x minus 4, x minus 4. So this is a case of a double root. It's going to give me the same answer. So I know x equals 4. There's no use plugging it in twice. Take that. If y plus x squared is equal to 4x, and I know my x is 4, I'm going to fill that value in. So 4 squared is going to give me 16 equals 16, so y equals 0. So this would be the answer for 0. And in this particular case, there's only going to be one solution. So that goes back to what we talked about on the first screen of sometimes you get two solutions, sometimes you're going to get one solution, and there are special cases where all your x's and y's would cancel out and you wouldn't be able to come up with any solutions. So that is looking at solving quadratic systems with linear systems.